I want to resume our class. This is chapter 7 about computer method. In other words, if we have too much difficult problem to solve with my hands, and I have to use the power of computer. That's what it is. Okay, and these two chapters may be very much useful, I guess, for your other studies. Because I will talk about general method, how to solve your matrix system, which is linear algebra. And also I will talk about how to solve your differential equation with computer, which are very much important, but not too much difficult as well. Okay, Gauss elimination, and you actually can go to mathematics department to study about this method, and many times we have C1 through Cn, which is unknown, and I don't know about this. Usually we call this as W in here, and usually we have so many coefficients. Actually, those are, we multiply this like that, right? For A11, C1, A12, C2, blah blah blah, and then A1, and Cn equals W1 is the first equation. Okay? So we have so many equations, and then An11 C1 plus An Cn equals Wn. So these are kind of so many linear equations. Okay, and we can express this relationship by using a less simpler expression like this. Okay, and what I want to do is, when you deal with this kind of equation, you can just keep multiplying things and try to cancel the term, and eventually, if I have, I can keep doing something, and then we can, if we make this equation like 0, 0, 0, 0, 0, and A and N, A1 minus N, and A usually minus 1, minus 1, things like that. And this is Cn and W1 through Wn. If you are going to be successful of making everything under here at 0, okay, then what is going to be my last equation? I will multiply 0 times C1, 0 times C2, 0 times whatever, and then eventually I will have A and N, Cn equals Wn, right? Then it's easy for us to calculate Cn, which is Wn divided by A and N, right? Simple. Then we will go to the second row from the bottom, and everything here is 0. And what we are left with is n minus 1, an minus 1, cn minus 1, plus an minus 1 n, and cn is equals wn minus 1, right? Now I already know my cn right there, so I can substitute. Then I can calculate my Cn minus 1. Pretty easy, right? Okay? Once you know Cn and Cn minus 1, then you will have 3 terms here. So we just move backward to calculate from Cn up to C1, right? So that's the principle of this Gaussian elimination. You have a system, you will make this one as so-called upper triangular matrix. Upper triangle, this is triangle, right? So upper triangle, you have numbers. But your lower triangle, you have everything is there. Okay? Somehow, if you are successful to make your matrix like this, and then it's a matter of back substitution to get answers. So now you're done. Easy, right? So what do we have to do? So, and this is going to be very tedious repetition, because if you have, let's say, 100 lines, it's going to be a nightmare for us to calculate, even to come up with this kind of thing. It can be done if you have no time, but it's time consuming. So, what is Gaussian elimination? I have forward elimination, which is making my augmented matrix as upper triangular, and then backward substitution, one by one. So that's all what it is. Okay, then also, if you take a look at, let's say, let's take a look at these two lines here. If you had these two equations, how can we reduce number of unknowns? In here, if I said this on Monday before, if you can multiply like this, and like this, right? And both side. It should be here and there. Okay? If you multiply this, I don't know about the rest of the stuff, there will be different numbers, okay? Because I will multiply this and that, this and that, this and that. For every term, I have to multiply the same coefficient. Also, right hand side vector as well. But what this one will make? This one will become A11C1, right? Then you have some equation that gives you some kind of possibility. If you subtract these two, then you can eliminate this one and come up with another. Let's see. Yeah, I guess so. I guess this is right. And this, let's say this one was originally 1, and I have times 1, which is A11, A21, A21, C1 plus A11, A21, A22, C2, A11, A21, A2, and Cn, A11, A21, W2, right? No problem. Piece of cake. Very easy, right? And then I will subtract. You can do it either way. From here, I will subtract this one. So then my first term is going to become. I don't actually have to calculate because I know I have 0. Because, right? Those are the same. Next one is going to become A12 minus A21, A21. It's a little bit complicated, but it's eventually just a subtraction from here to there. right? Okay? Very much important. Very much important. Very much important. Get it? What is this? This minus this. A12 minus this whole thing. No. Sorry. Okay? Okay? And then all the rest of the stuff will be the same. And the last term in here, A1n, A11, A21, A2n, Cn equals W1 minus A11, A21, W2. No matter what they are, they will eventually be just number, right? Value. Some value multiplied. This is constant, this is constant, this is constant. So, it's a number, okay? So you will have, now what we did was, we had things like this before, but by doing so, we can replace this one with this. It doesn't really matter. It's mathematically no problem. Okay? Linear combination of new line will give you the same answer. So what you did was you just eliminated this first one and you have this another equation, but still mathematically okay. And then we have third line, you can do the same, right? Third line we have like this. And then so in my first step, what I will do is this matrix is going to become all the zeros here. I have this kind of matrix, but my first line, in this case, everything was zero, because I did it. I can do the same for the next line, I can do the same for the next line, all the way down. Okay? No problem. And then, we'll just then take a look at this part only. Then we'll do the same. Then we can make zero, every zero here. And then we'll look the other line, we'll make every zero. Then if we keep doing it, and then eventually you will have all the zeros, and then just the one number right here. A11 through A n. You will have upper triangle matrix. That's Gauss elimination. Okay. Gauss-Seidel, we'll talk about it later. Gauss-Jordan, we'll talk about it later. TDMA, I talked about it. And TDMA then was, I said we had 2 unknowns for first row and 3 unknowns for all the rest of the row and the 2 unknowns for the rest of the row, and then we can have things like this. But in the computer world, these are already zeros. And if you have so many zeros, if you have to enter zero all the places, it's a waste of space and waste of time. So you can just reduce the number. I'm not going to talk about this too much in detail, but this Thomas algorithm is used to calculate this kind of system. This is called a TDMA, triangular, tri-diagonal matrix analysis. And so this is very much useful. So those are in the many different subroutines. So this is something like that. So they use the same routine. Okay, Gauss elimination. Let me use one of the example. You have let's say this kind of equation: x1, x2, x3. Those are 3 unknowns that I want to know. All right. In this case, my A11 is there. This is A and N. You can reduce this in the form of matrix analysis. and this one is my W1, W3. Okay? And then in here, they use a little different ways. In here, they use different method, but the principle is the same, and result should be the same too. And they use number 1 to reduce number 2. In other words, I said in here I could multiply 3 divided by 0.1 to reduce this one. But in other words, in here I can make this as 0.1. Okay? To make 0.1, I can multiply this by 0.1 and divide by 3. Everything there. And then once I have the new coefficient, I can subtract everything for this one. And then I can come up with this. That process is just like this. Okay? I will just leave my 3x1, 0.1x2, 0.2x3, 7.85. Okay, now I have 0.1x1, 7x2, 0.3x3 minus 19.3. In here, I will use number 1 and number 2. And I will subtract this one by using number 1. To make this one the same as this, I can multiply 0.1 divided by 3. And number 1. What is this? And this is 0.1 divided by 3 and 3x1 minus x2 and which is we can also use this one right there. Okay, so we will use this one and subtract. Then in this case, I have 0.1, 0.1, so I can cancel these two. Okay, what we have is 7 minus 0.1, 3.0x2, which is the same as 7.00333. Okay? And the next one is, let's see, 0.2 minus 0.22 minus right here, which is minus should be price. Anyway, and this is a little bit cumbersome to do so. So, in the calculation result for these two bits is this one, and calculation for this right hand side are this one. And then, so I am successful of removing my first term, because this one can replace my equation number 2. Okay? And the next step is I want to remove this one. Then what should I do? I will multiply 0.3 divided by 3 for number 1 and then do the same thing again. Okay? And then if I remove this one as well, then I have this relationship. No problem, right? And then what do I need to do? I will compare these two. I will remove x2 from this third row. What do I need to do? I will compare these two and multiply with something so that I can remove this one. So if I do it again, right? My equation is going to become like this. And once we have this one, it's going to be just a matter of calculating x3, and then if you have x3, you can substitute my x3 to there, and then to get x2, once you know x2, x3, and then you can calculate x1. That's the backward substitution that we have talked about. Now we have x3 7 something, And then we can just substitute my x3 to here to calculate x2. And then if I know x2 and x3, and then I can substitute those two to this equation and then to calculate x1, right? So now I have x1, x2, x3. If we have 4 lines, a little bit long, we can do that. 5, longer, we can do that. 6, too much long. We'll not do that because we're just asking my computer to calculate this. Well, for 3x3 matrix like this can be done by hand. Okay? From 4x4, it takes forever. It takes forever. And I have done it. Because when I did homework, I had to do it sometimes. But during the calculation, I could have made the mistake for the plus and minus signs, and then I get confused. It's very much annoying experience to do those with hand. Okay, what we eventually did was we had kind of matrix like this. Okay, this matrix did become like that, right? So 0, 0, 0. So this is forward elimination to come up with upper triangular matrix. And we can notice that we also did change this part. And sometimes we can make a mistake by changing terms in here only. But we know if you multiply something in here, we have to also multiply something. The same thing must be multiplied to keep the relationship, effective relationship. So we have that. So we can make this kind of process mechanically because we have the same principle. And the one we did was we compared these two. Somehow we came with this idea to multiply with the coefficient to there, and then simply subtracted this with number 1. And in here as well we did it, and we had different number, but we did it. So, and I want to check my solution. To check solution, the best way to do is we'll just put everything back into the original equation and see if we have the same answer. Even though we had a little error, dependent on our accuracy level, it's okay. Maybe not, but it's the matter of carrying a significant digit. In this case, I think we got error which can be acceptable in our case. But there are many different things that we have to consider. And I don't want to spend so much time because we have pivoting and the normalizing and scaling, things like that. And I don't want to cover because we don't have enough time. But you can read those through. But basic idea is I want to show you something in here. Okay, what we did in here is we picked this number and picked this number to have some multiplication factor right there. 0.1 and 3. What if this 3 is 0? No, there is no way we can calculate the coefficient if this is 0, right? So this one cannot be 0, but sometimes this can be 0. We don't know. It's possible, right? In this case, what do you need to do? Flip it over. Change the order. Okay? So the pivoting, normalizing, scaling, the rest of stuff is to minimize the error. So I will just quickly go over. I will just let's see. And if you have equation like this, equation like this, we can solve this equation, but depending on the significant level, if you carry 3 significant figures, which is 0.667, your solution in this case, and your y is, let's say, 2/3. And this one can be 0.667 or dependent on your significant figures level, you can have forever, right? So in this case, your x, if you have currently 3, if you put this back to your equation, your x will be -3. If you carry 4 significant digit, and then your x will be 0. And then from this time, you will have something similar, 0.3, 0.33, 0.3333, right? So from here, you could start to have this kind of right answer. But if you do not carry enough number of digits, then you will have trouble. So in this case, what we need to do is we need to somehow rearrange the order equation to minimize this. Okay? And we'll just then simply flip this over to here. We just change the order. Then solve the equation. Then, even though in this case I have same y, if we substitute back in here, then we could have 1/3 of x value. So the changing the order makes a lot of difference, right? For the the answers of x. These are wrong answers. These are mistakes. But mathematically, the process method is just right, right? But the answer is wrong. So we want to avoid those kind of stuff. But these are the job of mathematicians. We just use it. Thank you, right? So we're just, and in the computer code, we'll just take a look at all the questions there, and then we'll try to find the maximum one, and then put those back in here, and then we'll have, we'll be okay. So usually computer code, they can automatically take care of that kind of issue. So pivot is kind of the kind of center or something, but and we can the computer code, they have the small subroutine that they can take care of this accuracy issue. And if we come back to our computer code, in this class, I'm not going to ask you to write computer code, but I will ask you to understand what's going on. This is kind of it's not code, but it's not like a written flow sheet. And for this one, it says for the elimination process. Do means in here you have to iterate so many times, and if you are done with the iteration, and then go back to here, and then iterate again, and if you are done, and then you go back to the most outside group, and then have to complete the process. And if you remember, that we had to repeat. What we had to do was we have to repeat so many different processes here. If you have n equations, what you have to eliminate all the first part by calculating this one n minus 1 times, right? Because you have 1 and 2, 3, 4, 5, n, but the thing you have to make first term as 0. The number of lines for that is just n minus 1. Okay? So in here I have to do that calculation from n minus 1 times. Right? From second row, third, fourth, this will appear in your final exam. So wake up. Listen carefully. And you have to understand what's going on. And I will just ask you, what is that? What is that? Okay? So why do I have to calculate n minus 1 times? Because I have n minus 1 lines in there. And once you eliminate everything, then what you have to do is you just have to do the same business in here again. Okay? And then that is written for the next loop right here. Okay, and when you have k equals 1, k equals 1, and then your I is going to become 2 to n, right? And what is this? AKK. What is K? K was 1, right? And I now is 2. So in this case, AIK, AKK, K was 1, I was 2. What is this? And I will compare these two, right? And then I can have, this is my number, that I'm going to multiply this to here, and then eventually, by using this multiply the equation, I will subtract everything from here. Well, then I will have new equation. New equation. What was new equation? New equation, this one, right? And then once I have this one, I will do the same. And then the next A should be A, this one is 831. Next line is. So then at that time, next step, I will need A31 and A1. Because I will multiply everything, every term with this one, and then to remove this one, I will subtract my number 3 by using number 1. Okay? Then I will have this one. So let me go back to that kind of skeleton like code. This is not the code at all. But it's just a basic design of the code. So in here, once I have this one, I will multiply everything with this one. I will multiply everything here and then subtract from here and calculate again. So in here, my value J is 2 to n. 2 to n is from here, right here. Aij equals Aij minus factor. Factor is Aik, actually Akk, and Akj. It's a little bit difficult to explain with the word, but if you follow line by line, what it did was they changed every value in here. Every value. From line 2 and column n, you have to change it. And then you have to change your right hand side factor as well. Okay? So you would do that for second, third, fourth, and n. And after you're done, and you will just move to the next step and do the same thing again. Then this word is going to be your code. Very much efficient. Okay? if you do not have this, let's imagine that if you had to do it with your hand, it's gonna be forever. It's a lifetime. So we should be very much thankful, right? Thank you, mathematicians, to make my life a lot easier. Or I'm not really thanking you because you make my life terrible because of this one, right? Anyway, so we have it, and then once we have the upper triangular matrix, and then the next step is you just matter of back substituting the stuff. Okay? And back substitution is very, very interesting as well. And you have, let's say, A11, A1n, ANN, eventually, like this. Right? So, first thing that you have to do is, I want to calculate my last n by using my Cn divided by ANN. In here, they'll say this one is C. So my last calculus was Wn, and my answer in here is, which is the same as this one, right? In this case, they simply say this one is X and this one is C. So that's why they are at different names. And then for the next value, if you have Cn minus 1, and what you have to do is xn minus 1, and then let me just do this. an minus 1, an x n, right? What you did is use the right hand side vector right there, right? Okay, and then we will just somehow have this one. Let's say that there is some right here, and only thing that you have to do is divide everything by to get this one, an minus 1 and a minus 1. Okay? ai. Okay? For the second line in here, you just have only one term. But if you have one more thing right here, you know you have minus 2an minus 1, an minus 2an. You have two terms, okay? And this has to be moved to the right hand side, okay? So this is the summation. You have to calculate those summation and then somehow use that information to here to calculate x1. Because every time you will have to calculate xn, xn minus 1, xn minus 2, which is going to be using the diagonal element. Okay? If you are sleeping now, and you will have no chance to understand this one. It's a little bit confusing by just looking at it, but try to do it by your hand. You need just 3 by 3 example, okay? And it's gonna be, it's not gonna be too much difficult. And these are computer code right here. And I'm not going to ask you to use this one, but in here, as I said, in the real code, we have to play with the order of the equation to make my first coefficient, biggest coefficient should come to the first line. Otherwise, it's going to be easy for us to make errors in our calculation, as we showed before. Okay, so best way is just looking at all the coefficients in the first line, and if you have something the biggest and then move it to the first line and calculate. Then for the elimination and error substitution. Then you'll be happy. Okay? That's it. And those are orders of routine. Very simple. And then elimination subroutine. Very simple. And error substitution. Very simple. In this simple methodology of computer language will make your life a lot easier, because they will just do it for you mechanically in this right amount of time. Okay. Okay. So I just wanted to show you how the code looks like. Gauss cycle. This is somewhat empirical, very easy. It's kind of iteration. Iteration means iterative. Iterative means you just what is this? Do it over and over and over again the same thing. Okay? Keep doing the same thing is iteration. And very easy. You have an equation like this from line 1 to line n. If you want to know x1, we'll just move everything to here. It's like a calculating summation, just like I showed you before. Move everything to here and divide by n over 1. Easy, right? Second line, I want to know x2. I will move everything to the right hand side and divide this by a to 2. I want to calculate x3, do the same. xn, done. Happy. But this one doesn't make sense at all, right? Because in here I don't know x2, x. If I know exactly what those are, I can do it, right? But I don't know. In here, I even have x1 that I kind of, if I'm not really sure if that is right or wrong, and then I have it. In here, I have x1, actually it should be x3, x2. I think I made a mistake, and which is not right. But I will show you in practice this. Okay, we have things like this. We now know the solution of x1, x2, x3 are like that. Okay? We did it before. And I want to calculate x1. And x1 actually x1 right here can be calculated by using this relationship right here. And x1 is this. x1 is 2.61. What I did was, in here, at this time, I don't know about x2 and x3. So I will just simply ignore. Those are 0. Okay? In here, if this 0, 0, then my x1 is 7.85 divided by 3. Right there. Okay? But in here, I am not sure if this is right or wrong. But anyway, we'll just keep doing it. Now I have x1. My x2 can be calculated by, I will move everything to there and then divide by 7, which is right there. Okay? Now I know x1, I will just substitute my x1 to there and calculate my x2 as minus 272 somehow, right? And for x3, in here I can move everything to the right hand side and divide everything by 10, which is this, and this equation. At this time, I know x1 and x2. Ding, ding, and then I have 7. I will just do this just one more time. Now I have x1, x2, x3. I will just use this relationship at this time because I know x2, x3 now. And then calculate x1, which is 2.99, x2 minus 2.499, x3 7.00. What was the answer? What was the answer? 3 minus 2.5, 7. That was the answer. 3 minus 2.57. Almost the same. This two iterations. Very much interesting, right? In this case, you don't need any fancy technique. You just have to keep doing until you get the right answer. The method that you get the right answer is if those are converging to the right answer, they will give you the same answer. So you just have to compare the solution at this time with the previous time. And if those are close enough, then you can say, okay, I solved the problem. Very easy, right? Gauss diagram. And you probably like this method a lot better than the Gauss elimination. But in here, if you have to carry enough number with a significant number. And also they have a kind of a pseudocode you can follow. And these are like that. Gauss-Jordan method, and this one is like that, and this is inverse matrix. And you can somehow transform your matrix with like that. And once you have this form, if you multiply this row and this column, this one is x1. x1 is 3.0, right? And then next one in here we have on x2, which is minus 2.5. This is like that, and minus 7. If you can, then this means if you can somehow calculate inverse matrix, then it's better off just reading your right-hand side column to get your x values. Okay, so that's Gauss-Jordan. And you can do this by using your Excel program. And let's see, I have, well, let me just, maybe I have to enter all the values. Okay. Or I can go to my Dropbox. Okay. Let's try to save some time. Maybe we are not going to save our time at all. And I want to use this information right here. And I will just write coefficient minus 0.1 and minus 0.3, 0.2, right? And 7.85. And where is my second line? Second line, where? And 0.217 minus 0.2. And then I hope second line is right there. 0.3 minus 0.2, 10, 71.4, 71.4, and then how much was it? This one is 19.3. Okay. So I will just remove everything over there. Please go away. Okay. And then I will calculate inverse matrix from this one. So I will just pick like this, and then I will calculate M inverse, which is up to here, and this is my inverse matrix. And then I want to calculate M. No. Calculate equals M, because I want to multiply everything with this, and then this is my solution. 3 minus 2.57. Because in Excel, they have functions to calculate inverse matrix. So I chose this coefficient, and then this update by using functions inside Excel. This is inverse matrix. If I multiply this and with this, and then I get my solution. Okay? Very much easy. In other words, so I explained how to do it in here, right? Right there. Okay? I used M inverse to calculate inverse matrix. I used M merge to calculate solution right there. Okay? You just select the area and then use Ctrl Shift together and then hit Enter. That's it. That much easy. And so in here, the principle in here is if you want to calculate your x value, you just have to calculate the inverse matrix and multiply that with your right-hand side vector. So what I did was calculate the inverse matrix and multiply it together to get my x value. So this is it. Okay. And even though the matrix analysis is not in our textbook, and I wanted to go over, because this is very much important, For steady state analysis, in matrix is almost everything as a tool to solve the situation. And for non-steady, you have to solve differential equation, right? So differential equation, what? And that's chapter 7. What's the differential equation? So far, I did it. What I did, matrix. What is matrix? It's a movie, right? Matrix. It's not funny, right? Okay, it's about linear algebra. Chungnam, right? Linear equations. Early foundation. Okay? So we did it. And what I did is integration. Numerical integration? No. Differential equation. What is differential equation? This is dt equals something, right? This is differential equation. What I wanted to know in matrix analysis, what I want to know in here is let's say x, c. What I want to know is I want to do something to calculate my x or axis. Okay? Concentration for first segment, second segment, and so on in segment. I can use this method. In here, I want to solve this one, and I want just somehow this one function of t, whatever, and then I want to know I want to know what is C. If I can solve this one with my hand, I don't need numerical. I don't need computer. But as you all know, some differential equation is very strange looking, and it's not really possible that you can solve with your simple method or with a hand. But anyway, differentiation means it's a opposite meaning of integration, right? Integration, if we integrate this, then we can get somehow C value. Even though that can be very much discrete, dependent on your delta t. We'll just move with delta t all the time. It's not going to be continuous, but each t, anyway, we can have some kind of t value. This so means you need to have some condition. Okay, so in here, and if you have x and y, if this was delta x and delta y, and if you had kind of value from here xi equals yi, in here xi plus 1, and this is yi plus 1. And what I usually want to know is yi. What is next y value? Right? That's what I want to know. And but that have condition. If you know yi, if you know your delta y and delta x, then if you have delta x, then eventually your yi is yi plus delta y. Right? So what you can do? But how can we calculate this? How can we get this? And if we, by the definition of differentiation, if you send this to 0, we know this one becomes differential equation like this, right? So once you have dy dx, then we can have actually this one must be very much small, right? So if you have dy dx, and if you dx, then we can have the same result, okay? But condition is you need to have very small dx, because this one is almost, the interval is almost infinitesimally small, almost 0, but not 0. So this is the idea. So in here, what I want to know is Ci plus 1. If I have Ci, then I have maybe delta C. What is delta C? This is delta C over delta T. And if I have delta T, then we'll simply have to substitute that value to here. And where does this come from? Right there. So if you know your differential equation, you can simply put this one in here to calculate the next value. But in here, what we have to remember is condition. To calculate this one, you have to know the previous value. If you don't know, no way. You cannot even start. You have to know previous value, and once you know your previous value, then it's the matter of calculating your small increase or decrease. Because eventually your first differentiation is calculating your slope, right? So So it's just like that. But there is a problem. There is a problem. If you have just line, and you will have perfect answer. But if your system is very much complicated and it's not line, so this one will give you this value, but in reality your value may be around there. In that case, what you have to do, just to reduce to the integrated step. You have to just move. Then you can have a better answer. But you will never ever have the perfect answer by using this method, because this one is eventually, this is not the continuous line, just like our function. This is so many different collection of points that you keep calculating based on your previous information. Okay? So in numerical integration, you cannot just calculate this. You just have to start from here and then go. So it takes a lot of time to calculate all the values for your entire system. Okay, so I will just start with this one and then we'll close. And one of the best known method to calculate your C I plus 1, no, I would just let me say also y I plus 1, I said, is a plus delta y, delta x, and delta x. And this one is new, this is old or previous, and this one is slope, and this one is interval. Right? So in numerical integration, this is integration. You will just have to somehow add them together to come up with the next value. And you will use your differential equation. This is new, so because we will just add previous value and calculate this slope and calculate this interval, add them together. We call that numerical integration. We just add them together. Okay? So I want you to remember, your new value is going to be old plus delta y. Delta y is the multiplication of your slope and interval, right? Slope and interval. This is first differentiation. Interval, I decide. Okay? I can have this much big, I can have this much big, but if I have this much big, I can lose accuracy. If you keep accumulating the error, you will just go nowhere. So you have to remember, you have to pick right interval. But if you have too much small, it will take forever to calculate. To go from here to there, it takes forever. Then you don't have enough time. Then it's just like if you cannot do it, that means you say cannot do it, that means it's the same that you did not do it. So, okay, so I have dCdt all the time. Why did I have dCdt? I have dCdt. I want to calculate my CT plus 1. Then my CT is plus dCdt and delta t. Now, this dCdt is the equation, my delta t is a little bit different, but they start from this same principle. Okay? dCdt, I had a dCdt equals minus Kc, or if you have mass balance equation, you have something QC in, QC out, and dispersion something, and reaction something, and sampling something, right? If you just have to add all the incoming errors, subtract all the outgoing errors, and then come together and divide everything by V, then you will have dCdt for 1, 2, 3, 4, whatever. Okay? So as long as you have those kind of stuff, as long as you can calculate the first step, then you will be able to solve every differential equation with just this thing only. Done. You can send your rocket to the moon, or Mars, Jupiter, wherever. Because eventually those are finite difference method, and all the collection of the all the collection of systems of differential equations. It's a matter of how many, but computer can do it. They can just do forever. All right. So in here, I said if you have C1 and C2, if you solve it simultaneously, you can, no matter how many variables in here, you can do it. So you can do for phosphorus, you can do that for nitrogen, you can do that for algae, total organic carbon, silica, whatever. Okay? As long as you have DCDT, you can solve it. So now you know how to save the word, right? Because we just mastered the differential equation now. Happy, right? but that's always a problem. Always a problem. And let me just finish with this one. This one may look very simple and attractive, and that can be the method to save our word, maybe save our neighbors. But Taylor series. Taylor series. Fx plus delta x equals fx plus f prime x delta dx and f2 prime x delta x squared 2 factorial f blah blah blah. Taylor series. And what is this? df dx. What is this? This one is to calculate next value by using the previous value, you need entire degree of difference equation. What we did in here is we just chopped this part away, right? So this much will be your error. But if you have very small delta x, those are just square, power of a third, fourth, nth, and whatever. If there is 0.0001, and then if you multiply twice and 3 times, and then it even becomes smaller and smaller, and then also we'll divide them by these big numbers. So if you have very small delta x, it's okay to ignore those. But if you really wanted to send your rocket to the moon, you need a better method, right? In here I said if you have very small x to get very accurate answer, it takes forever. It takes forever. You have to just have too small delta x. In that case, if you have many equations, then you cannot solve the equation in a given time. In that case, you need a better method. To go from here to there, you can go by walking, running, taking bicycle, a motorcycle, or a car, sports car, whatever. If you want to go faster, you need a better method, right? So same thing. So there are lots of other methods that can be more useful. But everything has the same principle. New is based on old and slope time interval. And maybe those can be regarded like that. So some method can consider this much, some method can consider this much. But if they consider more and more, that means we need more information. Many times you don't have it. So better method may not be better sometimes. Because if you have, let's say, very big bus, if you don't have fuel, that's nothing for you, right? Okay, and so we now learned how to save the world or even the universe. So let's go for it. Okay, this is it for today. Thank you.